Hey guys, welcome back to Knowledge with Bro. I hope you all are seeing my previous videos and liking those. Have you seen my previous video? If you are seeing, then you must know who I am. I am Karthik Agrawal and I am currently studying in Sri Venkateshwar College of Engineering. So before we start today's video, don't forget to hit that subscribe button and like this video. So today we are here to talk about forced work petrol engine. So let's understand an IC engine. An IC engine, that is nothing but an internal combustion engine, is a heat engine that converts the chemical energy of a fuel into mechanical energy through a series of controlled explosions, and these controlled explosions happen in the chamber of the engine. Now let's understand the classification of IC engine. IC engines are classified into many types, such as number of strokes per cycle, types of fuel used in an IC engine, number of the thermodynamic cycle that happens in an IC engine, method of ignition, number of cylinders, or the arrangement of the cylinders. You can see the slide each type of classification and the types. I hope you all are getting some idea about an IC engine. Now let's understand some components of an IC engine. The first component of an IC engine is cylinder. Cylinder is the main body of an IC engine. Cylinder is a part in which the intake of fuel, compression of fuel, and burning of the fuel takes place. The main function of cylinder is to guide the piston. It's direct contact with the product of combustion, so it must be cooled. For cooling of cylinders, a water jack is used or fin are situated at the outer side of the cylinder. At the upper end of a cylinder head at the bottom head of the crank is bolted. The upper side of cylinder is consisting of a combustion chamber where fuel burns. To handle the pressure and temperature generated combustion of fuel. Cylinder materials Cylinder material should have high compressive strength, so it is made by high grade iron. Now let's understand the second key part of an IC engine, that is a piston. A piston is fitted to each cylinder, has a face to receive gas pressure and transmit the thrust to the connecting rod. It's it is a prime mover in the engine. The main function of piston is to give tight seal to the cylinder through bore and slide freely inside the cylinder. Piston should be light and sufficient strong to handle gas pressure generated by combustion of fuel. So the piston is generally made by aluminium alloy and sometimes of cast iron. So now let's understand the third key element of an IC engine, crankshaft. The crankshaft of an IC engine receives the efforts or thrust supplied by piston to the connecting rods and convert the reciprocating motion of piston into rotatory motion of crankshaft. The crankshaft mounts in bearing so it can handle the rotatory force freely. The shape and size of crankshaft depends on the number and arrangement of cylinders. It is usually made by steel forging. By some makers use special type of cast iron such as graphite or nickel alloy. Now let's understand the next key part of an IC engine, that is connecting rods. Connecting rods connect the piston to crankshaft and transmits the motion and thrust of piston to crankshaft. It converts the reciprocating motion of the piston into rotatory motion of crankshaft. There are two ends of connecting rods. One is known as big end and the other is known as the small end. Big end is connected to the crankshaft and the small end is connected to the piston by use of piston pins. The connecting rods are made up of nickel, chrome, or chrome steels. For small engines, the material may be aluminium. The next key component of an IC engine is flywheel. A flywheel is secured to the crankshaft. The main function of flywheel is to rotate the shaft during each stroke. It also makes crankshaft rotation more uniform. Now let's understand the next key component, that is valves. There are two kind of valve, inlet valve and outlet valves. To control the inlet and exhaust of the IC engine, valves are used. The number of valves in an engine depends on the number of cylinders. Two valves are used for each cylinders, one for inlet of air fuel mixture inside the cylinder and other for exhaust of combustion gases. The valves are fitted into the port of at the cylinder head by strong springs. The spring keeps them closed. Both valves are usually open inwards. Now let's understand the next key component, that is the spark plug. Spark plug is used in engine ignition. The main function of spark plug is to conduct high potential from the ignition systems into the combustion chamber to ignite the compressed air fuel mixture. It's fit on cylinder head. The spark plug consists of metal shell having two electrodes which are insulated from each other. I hope you all got some basic idea of the parts of an IC engine. Now let's start today's topic, that is four-stroke petrol engine. A four-stroke petrol engine is a type of combustion engine that operates in four distinct cycles and converts the chemical energy of petrol into mechanical energy. The working principle of four-stroke petrol engine is based on theoretical Otto cycle, that is at constant volume. It is named after a famous scientist, that is Nicholas August Otto. The four-stroke engine has four phases such as suction stroke, compression stroke, power stroke, and exhaust stroke. So let's understand the process of four-stroke petrol engine. The first process is suction or intake stroke. Intake stroke occurs when the air fuel mixture is introduced to the combustion chamber. In this stroke, the piston moves from TDC to BDC. The movement of piston towards the BDC creates low pressure area in the cylinder. The inlet valve remains open and to a few degree of crankshaft operates after BDC. The inlet valve then closes and the air fuel mixture is sealed in the cylinder. You can see from the diagram that the piston goes from TDC to BDC and the outlet valve is closed and the crankshaft rotates at the to the angle of 180 degrees. Now let's understand the second process of this of four-stroke petrol engine, that is compression stroke. In compression stroke, the trapped air fuel mixture is compressed inside the cylinder. During the stroke, the piston moves from BDC to TDC, comprising the air fuel mixture. The momentum of the flywheel helps the piston moves forward. Comprising the air fuel mixture allows more energy to be released when the charge is ignited. The charge is the volume of compressed air fuel mixture trapped inside the combustion chamber ready for ignition. The inlet and outlet valves must be closed to ensure the cylinders is sealed, resulting in compression. From the diagram, you can see the piston moves from BDC to TDC, that is from down to upward direction. Here the key point is both the valves, inlet and outlet valves, are closed and the crankshaft again makes an angle of 180, and adding the previous stroke, the total angle made by the crankshaft is 360. So let's understand the third stroke, that is power and combustion stroke. The power stroke occurs when the compressed air fuel mixture is ignited with the help of spark plug. Ignition or combustion is rapid oxidizing chemical reactions in which a fuel is chemically combined with oxygen in the atmosphere and releases energy in the form of heat. The hot expanding gases force the piston head away from the cylinder head. Here we can see from the diagram that the piston is again at the TDC and it is going down towards the BDC. Here we have to note that both the inlet and outlet valves are closed and The crankshaft makes a rotation of 180 degree. By adding the previous two strokes, the total angle made by the crankshaft is 540. Now let's understand the fourth and the last stroke of an four-stroke petrol engine, that is the exhaust stroke. As the piston reaches BDC during the power stroke, combustion is complete and the cylinder is filled with exhaust gases. The exhaust valve open during the stroke, and the inertia of the flywheel and other moving parts push the piston back to TDC, forcing the exhaust gases through the open exhaust valve at the end of the exhaust stroke. The piston is at TDC and the operating cycle has been completed. Here we can see from the diagram that initially the piston is at BDC and it goes to TDC. Here we should keep a note that inlet valve is closed whereas the outlet valve, also known as exhaust valve, is open, and the crankshaft rotation is at 180 degree. Adding previous all the three strokes, the crankshaft makes a total angle of 720 degrees. I hope you all got some basic idea of four-stroke petrol engine.